Good day, everyone. Welcome to another topic that I will be discussing today. I am Mom Princess, your guide in understanding the different fun concepts in science. Today, we're going to discuss the definition of voltage, current, and resistance, as well as how are we going to calculate these variables using Ohm's law. But before that, let us define the following variables, such as voltage. It is sometimes called as electric potential difference or electrical tension. This electrical potential difference between two parts of an electric circuit is expressed in a unit of volts with a capital V. For resistance, it is the flow of electrical charge, the amount of electrical charges flowing through the section in a second, and the standard unit for this is ampere with a symbol of A. And for current, it is the measurement of the difficulty encountered by an electric current through an electrical circuit. It is measured in a unit of ohms with the symbol of sigma. I have here a video on how voltage, current, resistance works and interact in different appliances we are using at home. So watch and listen to the discussion.
Suppose we take our circuit of a battery and a light bulb and we make it slightly more complicated by adding a switch. When the switch opens, the charged particles are prevented from passing through. Particles with the same charge repel one another, and they therefore spread out throughout the wire. The events shown here all happen at the same time, and this is the result. For the light bulb to turn on, the switch must close so as to create a complete path for the charged particles to flow around the loop. If we have several light bulbs, each light bulb can have its own individual switch. Or we can have one switch which controls all the light bulbs. The number of charged particles that pass by each second is what we refer to as the current. The charged particles flow through the light bulb because the battery causes them to have a higher potential energy on one side of the light bulb than the other. This potential energy is what we refer to as voltage. If both sides of a light bulb are at the same voltage, then no current will pass through it. As the voltage across the light bulb increases, the amount of current through the light bulb also increases, and the light bulb produces more light. When a switch closes, It causes the two different parts of a circuit that it connects to be at the same potential energy. If both sides of a light bulb are at the same voltage, then no current will pass through it. And if no current passes through a light bulb, then this means that both sides of the bulb are at the same voltage. A properly working battery ensures that the difference in voltage across it is always at a specific value. All points that are directly connected to each other through metal conductors and closed switches are at the same voltage. This means that if we have several light bulbs connected to a battery in parallel, the voltage across each light bulb is equal to the voltage that is produced by the battery. Since the voltage across the light bulb determines how much current passes through it, each of these light bulbs will have the same current pass through it as we had when we had just one light bulb connected to the battery. The total current drawn from the battery is the sum of all the currents drawn by each of the light bulbs. Now, let us consider a situation where we have several light bulbs connected in series. Since the total voltage across the group of light bulbs is at the specific value set by the battery, the drop in voltage across each light bulb is only a fraction of this. Since the current that passes through each light bulb depends on the voltage across it, this smaller voltage across each of the light bulbs means that a smaller current will flow through them. This means that the lights will not be as bright. Because the light bulbs are connected in series, this means that the current passing through each of them is the same. The amount of current entering always has to be equal to the amount of current exiting. This is what we refer to as Kirchhoff's current law.
So actually, this video is very useful in understanding the movement of voltage, current, and resistance inside the appliances that we are using in our home or to different objects or materials that are battery operated. So as I discussed a while ago, the definition of voltage, resistance, and current, they actually interact together. So as a summary of the video, here is the summary of the following quantity. For current with the symbol of I, it has the unit measurement of ampere or amp with an abbreviation of A. For the quantity of voltage, it is in a symbol of E or V using the unit of volt with the unit abbreviation of V. For resistance or R, it is in a unit measurement of ohm with the unit abbreviation of sigma. So let us now move on how are we going to calculate the three quantities or variables such as current, voltage, and resistance. These variables interact together in a so-called Ohm's law. This is the relationship between voltage, current, and resistance in an electric current. But actually, it is not really a law like Newton's law of motion. It is just a relationship of the three quantities of electric quantity. So here we have the triangular formula or the general formula for voltage, current, and resistance. Let us remember that as I discussed before, that there are two lines that represents the operation. For horizontal line, it represents the operation of division. For vertical line, it represents the operation of multiplication. So let us discuss it deeper. If you want to get or calculate what you are needed to solve in the problem using the given general formula, you can calculate voltage as current multiplied by resistance. For current, you can have current is equal to voltage divided by resistance. For resistance, it is equivalent to voltage divided by current. Let us have problem number 1. Calculate the voltage if the current is 0.5 ampere and the resistance is 2.0 ohms using Gressa. So, given current is 0.5 ampere, resistance is 2.0 ohms. Our required is voltage or V. For our equation, voltage is equal to current times resistance. For our solution, you just need to substitute the value 0.5 ampere multiplied by 2.0 ohms. So therefore, our answer for voltage is 1 volt or 1 V. It must be capital letter. Problem number 2. Calculate the current if the voltage is 1.2 volts and the resistance is 0.6 ohms. Using Gressa, given voltage is equal to 1.2 volts, resistance is 0.6 ohms. For our required, we need to solve for current or I. For the equation, current is equivalent to voltage divided by resistance. And therefore, for our solution, current is equivalent to, substitute the value, we have 1.2 volts divided by 0.6 ohms. And as you divide, the correct answer is 2 amperes or 2A. And problem number 3. Calculate the resistance if the current is 0.7 ampere and the voltage is 14 volts. Using Gressa, given we have current is 0.7 ampere, voltage is 14 volts. For the required, we are looking for resistance or R. For our equation, R is equal to voltage divided by current. For our solution, we just need to substitute. Resistance is equivalent to 14 volts divided by 0.7 ampere. And as you divide the two quantity or variables, the answer for resistance is 20 ohms or 20 sigma, the symbol for ohms. So here it is. That's the way how are you going to calculate the three quantities such as voltage, resistance, and current. Now, it is your turn to solve the different variables such as voltage, current, and resistance. Let us have problem number 1. Calculate the current if the voltage is 1.7 amperes and the resistance is 0.7 ohms. I am giving you a minute to solve this problem number 1. Okay, let us check. Given voltage is equivalent to 1.7 volts, R is 0.4 ohms. For our required current or I. Equation, current is equal to voltage divided by resistance. Substituting the value for our solution, current is equivalent to 1.7 volts divided by the resistance 0.4 ohms. As you divide the two quantities, the correct answer for current is 4.25 amperes or 4.25 A. Next, problem number 2. Calculate the resistance if current is 1.1 ampere and the voltage is 2.2 volts. Again, I'm giving you a minute to solve problem number 2 using GRESA. So let us check. For our given, current is 2.2 amperes, voltage is 4.4 volts. For our required resistance or R. For our equation, resistance is equivalent to voltage divided by current. So let us now substitute the value of voltage and current. For our solution, resistance is equivalent to 4.4 volts divided by 2.2 ampere. So as you divide the two quantities again, the answer is 0.5 ohms or 0.5 with a symbol of sigma. So that's it. We are done in defining voltage, current, and resistance, as well as in calculating the three quantities. You also observed and watched the video on how these three quantities interact together. So thank you everyone for listening. I am Mom Princess Paz. So kindly subscribe to my channel, Mom PM is the key, and do not forget to click the bell button to keep you updated. Goodbye!